talk about increasing and decreasing functions, I'm not going to lie to you, this is something I don't know very well. I forget it every semester and I have to review it. So obviously it's not something you're going to need for very long. You can actually use your calculator to figure it out if you get confused. So, I would say jot it down and be familiar with it, but also I'm going to teach you how to use your calculator to figure it out if you get stuck. Now what it is they talk about as the angle increases. So as an angle goes from 0 to 90, they want to know which trig functions are getting bigger and which trig functions are getting smaller. And so we say that they are increasing if they're getting bigger. So sine, tangent, and secant are bigger. So as the angle gets bigger, sine, tangent, and secant are bigger. Now, what that means is that if you have the sine of 40 and you have the sine of 80, which one's bigger? The sine of 80, right. Okay, and that's true for sine, tangent, and secant. The bigger the angle, the bigger the trig value. It is the opposite for the other three. Cosine, cosecant, cotangent. So when I do really stop and think about it, I just remember that the one with the C's are the ones that go backwards. So all the C's have what we call a negative relationship. Okay? So as the angle gets bigger, cosine, cosecant, and cotangent get smaller. So all of the C's have an opposite relationship. Bigger angle, smaller trig value. All of the non-C's, sine, tangent, and secant, they have a positive relationship. As A gets bigger, so does the function value. So here we're asked to determine whether each statement is true or false. The first one says that the sine of 21 degrees is greater than the sine of 18. So what you have to do is you have to figure out which one's bigger. Well, for sine, for secant, and for tangent, the bigger angle is the bigger value. So in this one, this guy is, on the left, is bigger. Does that make sense? Well, is it true that the sign here should be open to the bigger number? So that's true. So we think that's true. What I recommend is going and checking it in your calculator right now. Put your calculator in degree mode, type in sine of 21, and tell me what it equals to about the third decimal place rounded. Did you guys get 0.359, or no, 0.358? So if you're not sure, you can type it in. 0.358 is greater than, what's the sine of 18? .309. Okay, so we get 0.309 if I type in sine of 18. Is that a true or a false statement? So you can check these in your calculator if you get stuck. You might not be in the right mode. Check it and see if you need to go to degree mode. Okay? Let's pause then. Okay, so first let's see if we can figure out part B without a calculator. It's secant. So that means that the bigger angle has the bigger secant. So this is the bigger. If this is the bigger, is this the correct sign? So we think it's false. But let's go check it. And I'm going to go ahead and show you how to type this in your calculator. Use alpha y equals and type in 1 over cosine of 56. You type them in as their reciprocals. Yes, so you do 1 over the reciprocal. And then if you want, you can use second math and pull this up, and you can type in 1 over cosine of 49. And that's sort of like binary code, and it will either return a value of a 0 or a 1. If you're using that second math menu, be sure you close the parentheses after your trig functions, then you put it in proper fraction form, and that will tell you if it's true or false. So when you plug it in, what do you get? False. 0 is no, right? 0 is false, so we checked it. So it's up to you. There are tons of ways you can check that. You just have to find a way that you're comfortable with. If it's still not making sense, come see me. Okay, at this point, we want to back up to geometry. We want to talk a little bit about two very special triangles, the 30, 60, 90 triangles, and the 45, 45, 90 triangles. They're used a lot in architecture, engineering, surveying, all that good stuff. Physics, so they're very, very common, and we like to have exact values for them. So right now, your book is going to talk you through where 3 additional points on the unit circle come from. Okay, so we're going to start with the points 30 and 60 degrees. Your book says, imagine that you have an equilateral triangle, which is also equiangular. You have 60, 60, 60, and all side lengths are 2, 2, and 2. Got it? Imagine that you divide it into 2 separate triangles. It will produce 2 30, 60, 90 triangles. And each one of those, the bottom will be 1, so the short side will be 1, and the hypotenuse will be 2. Does that make sense? Okay, so we're in a 30, 60, 90 triangle. So let's take one of these and let's look at it. If we take one of those and we use the Pythagorean theorem, we can find that the long side, the missing side over there, is the square root of 3. Any questions so far? So you take a 2, 2, 2 triangle, divide it in half, you get a 2, 30, 60, 90 triangles, and it produces a side length of 1, 2, and you solve for a 1 here, a hypotenuse of 2, and you solve for the long side here, which turns out to be square root of 3. So far that's where we are. Once you have that triangle, you can find the trig functions by looking at SOHCAHTOA. So like, for example, if I want to find the sine of 60 degrees, then I look from this angle right here, and I do opposite over hypotenuse. So at this point, some teachers ask you to memorize that the sine of 60 degrees is square root of 3 over 2. I'm not a memory person. I usually just ask you to memorize a few points on the unit circle, and we'll go from there. Some teachers ask you to memorize this triangle. Personally, I don't care how you do it, just get it done. You need to be able to figure out a way to find sine, cosine, and tangent of both 30 and 60 without using a calculator. The unit circle usually works best for most students. All right, then if I try to find the cosine, that's adjacent over hypotenuse, which would be 1/2, and tangent is the opposite, which is square root of 3, over the adjacent, which is 1. So it turns out the tangent of 60 degrees is just square root of 3. Now we're going to go through and we're going to do the exact same thing for the 30-degree angle. Here, your book actually goes through the reciprocals with you. Do you want me to take the time to do that? Y'all are okay with that? Okay. No, I take it back. Your book's just going to ignore 30 altogether. But I guess we could talk about it, huh? If I wanted to find the sine of 30, that would be opposite over hypotenuse, sine. SOHCAHTOA. That would be opposite over hypotenuse. Cosine would be adjacent over hypotenuse, and tangent would be opposite over adjacent. So we could figure all of that out. Does that make sense? Now don't worry, I'm going to put all of this in a nice neat form for you before we leave here today, so don't get panicked. All right. Let's take a look at how they came up with all their 45, 45, 90 information. The only angle in that is 45 degrees, so technically we're only adding 3 today, 30, 45, and 60. If we imagine that we have a right triangle that has equal legs, so 45-degree angles, we let those 2 legs be 1, and we solve the Pythagorean theorem for the hypotenuse. We get a hypotenuse of the square root of 2. So that's where the side lengths come from in a...
Miss Hughes?
Okay, so let's try that again. Now we have what we need to complete a 45, 45, 90 triangle, and we can perform SOHCAHTOA on either one of those 45-degree angles. So we can see that the sine is the opposite over the hypotenuse, which is 1 over square root of 2, and that rationalizes to square root of 2 over 2. So there's a value you'll need to memorize. Cosine is adjacent over hypotenuse, which is the exact same. So for 45 degrees, sine and cosine are the same, which is really nice. If you rationalize it as well, you get square root of 2 over 2. The best part about 45 degrees is the tangent value. The tangent value turns out to be 1. Opposite over adjacent is 1 over 1. So that sort of brings it all together. If you're interested, you could also do the reciprocals. You can see there where we did the reciprocal of cotangent, this reciprocal of tangent, and got 1. 45 degrees, the reciprocal would be of cosine is secant, so we get square root of 2. And the reciprocal of sine is cosecant, and when we flip square root of 2 over 2, we end up getting square root of 2. You can usually find those. If you know one, you can find the other. That brings us up to this big chart. I've never had any success teaching with the chart, just like the chart where they gave you the quadrantals, I find that I don't memorize charts well. Now, some students do. They can close their eyes and they can see that thing in their head. And if you are one of those, more power to you. But I am not. But here's what we just did in those last 6 or 7 slides, just all put together. I don't know about you, but I don't want to memorize them. Do you? No? Yes? You want to memorize this? Have a quiz on it? No? Okay. Well, let's build it from the unit circle. So let's start over with our unit circle and what we know so far. Tell me about the unit circle. What's it do? What's it used for? The unit circle is a set of ordered pairs on the coordinate plane that are associated with common angles, including the quadrantals, plus 30, 45, and 60. When we're finished, there will be 16 or 17 points on that unit circle, but you only have to know 7 of them to really get the job done. That's the good news. You already know 4. Let's go back through those. On the unit circle, let's talk about our quadrantals. This is the point 1, 0, that operates as 0 degrees and as 360 degrees. This is the point 0, 1, and that operates as the 90-degree point. This is the point -1, 0, and that is your 180-degree point. This is 270 degrees, and that's the ordered pair 0, -1. Remember that for every point in the unit circle, the R value is 1. So we're not in SOHCAHTOA anymore. We are back on that coordinate plane system. So for your unit circle, you think of yourself as being in a coordinate plane again. And remember that you just use the definitions to find what you want. So far, so good? Okay, so those are the 4 points you should have memorized. Just real quick, refresh me. If I want to find the cosine of 180 degrees, how do I do it? I go and look at the point that goes with it, and the cosine is defined as what? X over R. So the cosine of 180 degrees would be -1 divided by an understood 1. So that's just -1. So the cosine of 180 is -1. That's the nice thing about all of these is that, you're stacking them over R usually, So what that means is that the X value of these points is acting as the cosine value, and the Y value is acting as the sine. In fact, R sort of becomes unimportant because he's a 1. So let's add our 3 new points that we need to memorize. We're going to draw some points out here, and we're going to let this be the 30-degree mark. In the middle, we're going to let that be the 45-degree mark. And then way up here, we're going to let that be our 60-degree mark. So that total angle right there is 60 degrees. So the biggest one is 60, the middle one is 45, and the next one is 30. Here are the 3 ordered pairs. This one is 1/2, comma, square root of 3 over 2. This one is square root of 2 over 2, comma, square root of 2 over 2. And this one is not reciprocal, but the switch of this one. Like if I switch X for Y and Y for X, sort of the inverse of that point. So we have square root of 3 over 2, comma, 1/2. So if you know where the 1/2s go, you can usually figure these 2 points out. And then the middle one's always square root of 2 over 2. If you wanted to find tangent, you could stack the Y's over the X's, because that's the definition of tangent. I recommend going ahead and memorizing the tangents that go with these 3. I have them memorized. It doesn't take long. If we stack Y over X here, we'll get square root of 3. So there's your tangent value. This one divided by this one would just be 1. And this guy ends up being 1 over the square root of 3 if we stack him. 1/2 divided by square root of 3 over 2, which is 1/2 times 2 over the square root of 3. And you can see that's 1 over the square root of 3, but rationalized, he is the square root of 3 over 3. Those are your kind of unit circle points there that you need to know. If you know those 7, you can do a lot. So really, it looks like a lot to memorize, but if you just start drawing it every time you use it, and it'll eventually get a lot easier for you. But you have to associate the proper point with the correct angle, or it's never going to work. Do you have any questions? No? Okay, let's practice for a minute. Let's say I ask you to find the cosine of 60 degrees. What is it using that drawing? Go to your 60-degree mark. You know that you're on this point right here. Which of those two values is the cosine? The x, because it's the same as having x over r, which is x over 1. So what's the answer to this problem? 1/2. Okay? Let's say I ask you to find the sine value of 30 degrees. The sine value of 30 degrees means I should be looking at this point right here. The sine value is the y over the r, which in this case is just 1/2 over 1. So that is 1/2. That should make sense from our cofunction identities. Sine of 30 should equal cosine of 60 because they're complementary. And finally, let's say I want to find a secant value. Let's say I want the secant of 30 degrees. This is a little trickier. Well, first off, secant is the reciprocal of cosine, correct? Yes? Okay, so go find me the cosine value of 30. Look up at your unit circle, find the 30-degree point. Which of those two values is the cosine? The x or the y? Cosine is defined as x over what? R. So which of those two is cosine? X. The first one. So this is your cosine of 30 degrees here. That's the square root of 3 over 2. But if I want the secant, I don't take that, I take the reciprocal of that. So the reciprocal of square root of 3 over 2 is 2 over the square root of 3. And then you rationalize. We have 2 square root of 3 over 3. Are your brains just fried today? You're very, very quiet. Did that make sense, or do you just need some time to memorize it before we talk more about it? Okay, do not put this off. Even though it may not make a whole lot of sense right now, memorize these 7 ordered pairs and the angles that go with them. If you don't, you are going to regret it. This is the biggest thing for the first 3 chapters is memorizing this unit circle. Absolutely the biggest thing. So start memorizing it now. We will have a quiz on it relatively soon.